Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hey, it's the Distributed Data Show. I'm Jeff Carpenter, and I'm here in the studio with Patrick McFadden.
Hey, Jeff. How you doing?
As is often our habit, we have on the phone, on the line with us, we have Luke Tillman.
Hello, fellow humans.
Good to have you, Luke. And we also have Mr. David Gilardi.
Hello, hello.
Coming at us live from the lovely state of Florida. Also, we have an additional East Coast guest with us today. He is a solutions engineer here with us at DataStax, Sebastian Estevez.
Hello, folks. Thanks for having me.
It's good to have you. I hear you're a man of many talents. So why don't you give us a little bit about your background and what you do here at DataStax?
Sure. Yeah. So I've been with the company about 3 years, and I've had 3 roles throughout those years. The first thing that I did was work for our startup program. So for those of you guys that aren't aware, we do give out our software for free to small companies. We have had historically varying levels of support for that. For my first year and a half at DataStax, I was kind of free help for the folks in the program, which means I interacted with lots of small companies with not a lot of resources trying to do really awesome and possible things with our software. And that was a lot of fun, and I learned a lot about distributed technology in general, and very specifically about DSC. After that, I took on a similar role as an SC, as a solutions engineer in the Northeast with enterprise customers, helping basically them start out on projects and undertakings with DSC. And finally, most recently, maybe about 6 months ago, I moved to our Vanguard team. That's kind of a concentrated, smaller team within the solutions engineer team that's focused on our more strategic accounts, internal enablement, things like that.
Wow. Well, I'm super stoked that you're here. You know, I'm a big fan of the Sebastian show. You've always done really good work. And I've always enjoyed your presentations about some of the more, I'd say, truthy parts of, running a large scale system, how our product works. You know how to make it work really well. And that's why I'm really excited you're here today. So what do you have to share with us today?
Yeah, so I like that word truthy, right? Because distributed systems are hard, right?
Really hard, yeah.
Yeah, and I've been thinking a lot recently about distributed graph technology, specifically kind of real-time transactional graphs like DSE graph. And it's certainly, I think in my eyes, it's a little bit of kind of the next frontier in distributed data. And it's also, so it's something that's evolving fast, something that's changing, that's hard to do, but something that's got a lot of value add as well.
You remember one time we were talking, and I didn't really quite, this is a few years ago, maybe a couple of years ago, you told me the future is graph. And that was the first time I'd ever heard someone say that exactly. And it was from you. So congratulations, it's working out.
All right on.
Yeah.
I don't remember that conversation. I would have expected that Matthias or somebody told you that.
No, you did. Congratulations, you did.
All right. Yeah, that's great. Well, I've been doing a lot of thinking about graph and a lot of working specifically around how to basically write performant Gremlin queries using DSC.
So for somebody that's out there listening to this, they're not going to have any idea what you're talking about. Gremlins, I'm thinking we need some more Mogwai on this show. This was an awesome 80s movie. But if somebody doesn't know what a gremlin is, explain to them, what is Gremlin and what is a Gremlin query? Why should we care?
I think my uncle drove one of those back in the day.
Yeah, there was an AMC car, the AMC Gremlin. Fantastic vehicle. No, you should never drive that. It's like a Pacer, but worse.
All right. Not about movies or cars, Dan. So yeah, let me actually give a little bit of background. That'll be useful for folks that haven't gotten into the most recent wave of kind of graph technology. There's a few different graph databases that are kind of coming up and that have been growing over the past bunch of years. And to kind of bind them together and have a little bit of a community effort and a community effect, there's also some graph standards that are coming out and that are gaining a lot of momentum. And so most of these graph databases support those standards. The standard is called Tinkerpop, which is an Apache project. It's another weird little word kind of like Gremlin. Basically, Tinkerpop consists of this cast of characters, right? A whole bunch of little kind of cartoony, very beautifully drawn, and they have their own personalities, little characters. And each of them represents like a different layer in the Tinkerpop stack, right? In that set of standards for graph databases. And so at the top of that stack, at the interaction layer between the graph database and the user, right, the developer, we have a query language called Gremlin. The way that I like to describe Gremlin is if you picture your graph, which is just a bunch of vertices and edges, right, nodes and things that connect those nodes, and you can kind of take your ERD and turn it into just a graph by drawing it on a whiteboard, really. I like to talk about Gremlin by thinking about picturing a little gremlin guy on the graph somewhere, standing on maybe a vertex, and then through the language, which is a functional language, turn complete, composed of things called steps, you can tell that little gremlin to jump around that graph and to move up and down and in and out and over through the vertices and through the edges, right? And so, kind of the goal and the purpose of Gremlin is to give you high transactional or high traversal expressivity, right? When we say the Gremlin traversed the graphs, we mean he jumped around the graph, and the language is very expressive. You can make him do backflips and front flips and all kinds of stuff, right? He even has a little sack that you can put stuff into, right? All sorts of things. Yeah, and so
this
because
is
of that,
getting really weird with all the analogies.
Not like that movie I was just referencing.
At one point, do you put it in a blender? Because I remember that was in the movie too.
Don't get him wet.
Yeah, that's it. That's it.
I'm going to go back on Netflix after this and check this out, because I'm clearly not getting any of the jokes.
Yeah. Well, yeah, that's kind of we'll put that in the show notes, right?
And like half of our audience is right there with you.
Here's like IMDb link. Please read this because it will make more sense.
Yeah. Well, because of all that cool traversal expressivity, there's a lot of ways to get the data that you want from the graph database, right? That's kind of what it comes down to. And so the reason I'm spending a lot of time on Gremlin queries and optimization is because you could write a Gremlin query that gets you the data, but you might write it really inefficiently. It might take a long time, right? Whereas you might write it kind of the right way, knowing all the underlying structures of how things work under the hood in DSE graph, and then you'll get some very performant queries that get you the right data. And so through that scope, I've been thinking a lot about how to improve people's experience.
Okay, so can you tell us a little bit why optimizing a Gremlin query is necessary, or how it's useful?
Yeah, for sure. So I think that a lot of folks are going to jump into their developer tool, most likely DSE Studio, which is a really nice tool to kind of play around with and visualize and write their queries at. And they may hit a query and it runs and it times out, right, or something like that. And so there's kind of a little bit of techniques and strategy and tactics to be able to get really good results from your graph queries, because at the end of the day, this is a distributed system with tens or hundreds of machines running around, and the data may be a lot of places, and it's very easy for you to kind of go write something that just simply won't come back in a transactional sense, right, within a timeout.
Oh, okay, so we need some more details here. We have time, right? Let's dig into this. What are some of those tactics specifically that we can use to get more performant Gremlin queries? Yeah,
definitely. So, kind of the way I've been approaching the problem is iteratively, right? And so I like to start with the first thing I'll do is I'll slap a time limit step on my Gremlin query, and you guys can check out the Tinkerpop documentation for what that looks like. But basically you say .time limit and you give it a number of milliseconds, right? And that's going to be the maximum amount of time that the query will spend running at the Gremlin server within DSE, right? And so at that time, after those, let's say 100 milliseconds have expired, it'll take the data that's got so far and shoot it back to you, right? And so that means that you won't kind of be waiting forever for something to come back or time out. You'll just be able to get responses and kind of troubleshoot through your queries and make sure you're getting what you want. kind of without losing all your time, right? So that's kind of the first thing that I would say is really useful, is to slap a time limit in your queries.
Is that like enforce my SLA kind of thing? Would you use it in that case?
You kind of, I guess you could, but maybe not. I guess it depends on how sensitive you are to the data that you're getting back. If you need an entire result set, or if you're really just looking for kind of the first 10 things, and you could also, so this is very similar to a limit clause instead of number of things I want back. I just want whatever you got so far to come back within 10 seconds. Right. So I guess in some cases you could use it to enforce an SLA. One thing to note, that's not like the query, that's not the query back and forth time, right? You're still pushing stuff through the network, over the wire, back onto your client, and it's just the amount of time it'll spend within the Gremlin server inside POC, probably at the coordinate. So so that's the first thing, and there's a few other tactics, but I think maybe one of the interesting parts about this whole thing is that now that Gremlin queries are so expressive and there's so many different ways to get the data that you want, we're back in a world that, again, is really different from CQL, which a lot of kind of distributed database folks might be used to, where you're doing pinpoint queries and you know exactly where they are on disk, and so you just seek over and you scan the right parts of disk, and there's really only one way to get that, right? And maybe you have a couple replicas, but that's it. On the other hand, with Gremlin, like, you are doing kind of complex stuff. You can, go through a bunch of the vertices. You can group count. You can do all these things, right? And so that means that there's a lot of ways to do it. And so we're back in the world where we have something like an explain plan, and where we have query profiling that's actually really deep, kind of like we used to in RDBMS, right? And so kind of things kind of go in circles like this. And so kind of coming back to your experience sitting in front of Studio and trying to come up with some good queries, well, also slap a .profile at the end of that query, because that's going to tell you the different kind of steps that are happening underlying and where you're spending time. And so you can kind of take the big ones and try to narrow them down. And it'll also tell you, if you're leveraging indexes within the database, right, which is a significant kind of performance improvement. Right? So if you're going to have scalable queries, you want to make sure that you're picking up your indexes, and you can see that in the profile.
So this is a pretty new thing. Like Patrick kind of alluded to it, I guess, a little bit. 2 years ago, he had this conversation with you when you told him graphs were the future, all graphs. And so give us a sense, how fast is this technology evolving?
I think it's really evolving super fast, right? So one of the things in my thought process, I've been working with a bunch of customers to help them build fast Gremlin queries, is I've seen the same kinds of problems and the same kind of tactics over and over a couple times. And so I've been writing those down. Like those thoughts that I've been writing down, I'm actually hoping and kind of seeing that they're quickly becoming obsolete, right? Because in the same way that now we have explain plans and profiling back in our queries like we used to in the old days, we also have a database optimizer, right? And that database optimizer gets better. And so something like a Gremlin query that is written efficiently in X way and can be rewritten in Y way to make it faster, well, some of that stuff's going to start to happen automatically. And so I think like in the next release, there's one that actually improves the way we handle the ORs and the AND steps significantly. And so now you don't have to kind of think about it that much. So I mean, in this world, as the optimizer gets better, your same code with your same queries is going to just gain performance as releases come out, which is pretty cool.
That's hard to keep up with. I mean, I was just at Graph Day in San Francisco, and the talks there were, of course, on this topic you're just talking about, like how fast things are moving and trying to keep up with it. We're preparing for Graph Day in Seattle, which is in October. Same story. I'm sure there's going to be something new and cutting edge there as well. And it's great to keep up with it. And that's why, I keep going to these conferences. I think, and these are getting bigger. These graph conferences are now growing. They're not just meetups anymore. But if I want to learn more about this, I mean, where would I learn more? Who are the people I'd reach out to? I mean, give us some idea of where to go, because this is confusing and we need help.
Yeah. So, one shameless plug, the DataStax Engineering blog has a lot of great material, including a blog post specifically about tuning your Gremlin queries. I called it good, better, best Gremlin queries, something, something, something. Maybe we can put a link down here too.
By Sebastian Estevez.
Yeah.
That
There's
guy.
A bunch of,
he's really good, I hear.
anything on that same DataStax Engineering blog by Marco or there's a couple of really good ones on Matthias as well, are definitely worth your read if you're kind of going through, kind of dive down the graph rabbit hole. Some of those are pretty dense, but there's very useful, awesome nuggets in there. So really good material. I think the number one place to go, as with everything BSE, is to start off with DataStax Academy courses that are beautifully filmed, and I mean that's something that I'm hoping folks are really taking advantage of. And we also have the DSA Slack now, right? How do you folks can get there on the website and sign up?
Yeah, if you have a DataStax Academy account, it's part of that. You can ask for an invite, or one can be on. You can just go to your profile and say, "Send me an invite." It's automatic, no humans involved, which I love. But once you're in there, there's a channel for Studio, there's one for Graph, and then there's some other general things. Just lots of topics, lots of
and
experts.
for this show, we have a channel for this.
That's right. With Distributed Data Show, we have a room in there or a channel in there. So yeah, plenty of places to ask questions and interact with other users.
Awesome. Yeah. So a lot of us at DataStax try to spend some time over at the DSA Slack channel once in a while. I know a lot of people in this room, so that's a good place to get help as well. Yeah.
Wow. Well, this has been a wealth of information, and your blog post, I think, is a good follow-up for those people that want to read what you've just said. It is a new technology that once you start to get to know how to use this is really helpful information as you're starting out. And like, how do I make my best queries, and what are the tricks and things? And so this has been really helpful. Thank you very much for joining us today.
Awesome. Thank you guys for having me. Very excited. I love that the show is back.
Yeah. Well, and for everyone out there, thank you again for joining us, and we'll see you next time. Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.